This proof, we have another case of not just showing that two triangles are congruent, but to apply that further to then say that two angles are congruent afterwards. And so in our given information, you see we have that keyword bisect again, meaning to split into two equal parts. And so we have a segment MP running through our diagram, and it is bisecting two different things. It is bisecting angle M, so we can find angle M, which is over here on the left, and we see angle M has been cut into two parts. This angle above segment MP and this angle below segment MP. And we should know that those two parts are equal because of the word bisect. So it wasn't given that these two angles are equal. What was given was the word bisect. And so we should know that we can apply the definition of an angle bisector because we've split an angle in half. And for a similar reason, we see that we're also bisecting angle P. And so we go over to angle P. We see that has also been broken into two smaller angles, the angle above this dividing line and the angle below. And once again, that is simply the definition of an angle bisector, because in our given information, we are told that we had this idea of bisecting. And so I've forgotten once again to mark these over here. So let's mark our angles in this congruent triangles diagram here and here. And we need a third piece of information, and it has to be one of those guarantees. So we don't really have very many. It's either vertical angles or reflexive property. And we see that the two triangles do happen to share a side, and reflexive property says because they both use that side, then they have a congruent side. Of MP. And so we mark it there, mark it here, and you can see the layout, especially if you just look at one of the triangles. We have two pairs of angles and the side connecting them, and that would be angle side angle, stating that the two triangles are congruent. And so which triangles are congruent? How you start this is up to you. We could say this is triangle MLP for the top triangle, and if you did that, then you'd have to name the bottom triangle as MNP. So all corresponding parts are congruent. And now that you've done that, you should see that according to your congruent statement, angle L, which is listed in the middle here, is congruent to angle N, which is also listed in the middle here. And that's the whole idea of being congruent. If two triangles are congruent, then all corresponding sides and angles are congruent. And the simple reason for that was those 5 letters CPCTC. Just saying that you have congruent triangles, meaning all angles and all sides must also be congruent.